Okay, before we start, can I please just get confirmation that you guys can hear me, please? Okay, perfect. Okay, so for now, and then I'm guessing you guys can see my screen. I do apologize, my camera is not working, so we're just gonna go without it for now, okay? So good morning, Assalamu alaikum guys. Welcome back to grade 9 maths by Inspired Teens. When today's lesson, we're actually going to be going over a past paper. We're not going to start next term's work just as yet. We're going to be going through a past paper because we are finished for all the topics for the term. Yeah, I'm guessing most of you guys are on holiday. Yeah, we'll be continuing with lessons during the holiday. We'll do like maybe we'll see how it goes, right? I think you guys are going to be opening around the 12th or 11th again. So that gives us I guess, another weekend of tuition in the holidays. So let's see, maybe I want to just try and avoid starting with syllabus in the holiday because I feel like some people are not won't attend during the holiday. So let's see, maybe you guys can tell me as well. In the end, I'll ask you guys again, what would you guys prefer, to start with new stuff or to just go through past papers and solidify term one's work? You guys can let me know, or we can start the work, get ahead already, and take it from there. Okay, so let us begin with a question from November 2020. So we should be able to, we'll see, we should be able to do this entire past paper. I think we've covered almost everything. But yeah, okay. Section A, question 1, answer the following question by circling the letter next to the correct answer. How many terms are in the expression? Okay, so what we want to do here is, do we want to simplify? That's the question. No. Okay, let's come back to that. I'm not sure if we should simplify or we should just judge it from there because it's multiple choice, but nevertheless, let's come back to it. Let's look at 1.2, okay? Which of the following is not an example of a rational number? So in this case, okay, we need to remember what a rational number is. Remember, we defined a rational number as basically a number that we know the entire value of. Okay, so if we consider something like pi, which is a decimal, there's no simplification, so because it's for 1 mark. No, I understand that, but it doesn't matter. Like, even if it's for 1 mark, sometimes for multiple choice, you will need to do calculation. Okay, but we can come back to it. I'll simplify it myself. I'll answer the question and then we can approach it. Okay. Just so that I can tell you guys what's the best method to follow. Okay, so yes, so we said a irrational number is a number that has a decimal that continues forever and ever. So for example, pi, which is equal to 3,14, and it has an unlimited amount of decimals, right? If we write a few more, we have 3,14,15926 ... and it goes on forever. It's irrational, okay? We cannot tell the entire value of that number. So basically, we're going to assess. So obviously 5, we can do process of elimination, which is good for multiple choice, meaning you cancel out the ones that you know are definitely not true, okay? The ones that are obviously incorrect for that specific question. So in this one, it says, which of the following is not an example of a rational number? This is a rational number, definitely 5, and 2.5 is definitely a rational number as well, because we know the entire value, okay? If we have some more knowledge on our exponents, if we remember our exponent rules, this is actually from a surd rule. When you have a surd of a fraction, you can actually turn the numerator into a surd and the denominator into a surd. Okay, so that's one of the surd rules, which is very similar to the exponent rule as well. So in this case, we basically have square root 1 is 1. Okay. Square root 1 is 1. Square root 25, that would give us 5. And this is equal to 0.2. That's it, right? There's no other decimals. It's just simply 0.2. So again, process of elimination, right? We say that was out, and now we know that's out. Alternatively, yes, you could substitute the square root 1 over 25 into your calculator, but it's better to revise your surd rules at the same time. However, then if we look at B, this is the obvious option, but then we can put square root 5 in our calculator to double check, and square root 5 is going to give you an answer of 2,236067977 ... So this is our correct answer, B. Okay, so B is not an example of a rational number, it's an irrational number. Let's look at 1.3. Choose a statement that describes how to determine the next pattern, the next term in the pattern. So here we have 1, and we have 1 over 2, then we have 1 over 4, 1 over 8, 1 over 16. So the best method would be just to analyze it, okay, from inspection to see what is happening as we're going from one term to the next, to the next, to the next. So there's options: add 2, add half, multiply by 2, multiply by half. Okay, so if you remember, right, from the patterns that we learned, when we add, we said when we add or subtract, we call those linear patterns. Okay, we didn't really give the multiplication a name, but the multiplication is actually called exponential pattern, I think. Okay, exponential patterns. Jeez, my memory. Give me 1 second. Let me double check that term for you guys. Okay, but yes, while I look for that, what do you guys think this answer is? How are we obtaining the next term in the pattern? Okay, we're saying D, so we're saying multiply by a half. We have arithmetic and we have geometric, yes. So these are called geometric patterns. Okay, when you multiply. I don't think we did the exact names for them, if I recall from last week's number pattern lesson, and I know some of you didn't even learn formulas for these, but yes, the arithmetic or linear pattern, that's when we add or subtract, and then the one where we multiply. So you could even say technically divide, but we don't really say divide, right? Because if you're going to multiply something by a half, it's like dividing by 2. So we just choose multiply it by a half instead. Okay, and those type of patterns we call geometric patterns. So yes, in this one, you could try to say, so if you're not sure if it's linear or if it's geometric, okay, you could try to say T1 minus T2, sorry, T2 minus T1, and check if it's equal to T3 minus T2. If that doesn't work, okay, you could then try T2 over T1 and check if it's equal to T3 over T2. Okay, and in this case, this is not going to be true because a half minus 1 is negative a half. A quarter minus a half is negative a half as well. No. A quarter minus a half is a negative a quarter. Okay, so in that case, this won't work. So you know certainly it's not arithmetic. When we try this, on the other hand, when we say 1 over 2 divided by 1, we get 1 over 2. When we say 1 over 4 divided by 1 over 2, we get 1 over 2 as well. Okay, so in this case, you can identify that, okay, there is a constant ratio in this pattern. And by doing this calculation, so this constant ratio confirms it's a geometric pattern. And by doing this calculation, you will actually get R, which is the constant ratio, which is actually what you do from one term to the next. To get to the first term, to the second term, that's what you do. Okay, so that's a more tactical approach using the formulas and everything. But if you're using inspection, you can see that your denominator is increasing by 2. It's increasing in multiples of 2, like 2, 4, 8. It's multiplying by 2 each time. So it's actually increasing exponentially. So in that case, right, remember when you multiply fractions, you multiply numerator by numerator, denominator by denominator. So we can see that the numerator is remaining the same. So by each numerator, we are multiplying by 1. So we know certainly that our change in our numerator is 1. Okay, so it's multiplied by 1, because when we multiply 1 by each time, we get 1 and 1 and 1 and 1. However, the denominator's change is multiplied by 2 each time. So then it's multiplied by 1 over 2. Okay, that's by inspection, which is, I'm guess. Is something wrong with the sound? I don't know. Is it everyone, or is it just you? Is there something wrong with the sound? I'm not sure. You have to tell me. Yes. Like what's wrong with it? Is it soft or what? No. It's like going soft. You break up, then it comes back. Okay. Is that happening for everyone, or is it just for some people? I've made my sound, I can make it slightly louder. Not happening for everyone. Okay, it might be connection. Maybe try reconnecting and then tell me if it's still giving the same issue. Okay, because it's not for everyone. Okay, let's move on. 1.4, complete square root 13 squared minus 5 squared. Okay, so this is simple. We can simplify this. 13 squared, okay, is 169. Minus 5 squared, which is 25. When we say 169 minus 25, we get square root of 144. Square root of 144 is 12. Okay, let's look at this. 1.5. Given the table, identify the formula that shows the relationship between X and Y in the table given. Okay, so what is your guys' answer for this? What do you guys think the answer is for this? Okay, we have one person saying D. Okay, so there's multiple ways to approach this. Okay. The first way, again, by inspection, by just looking at your problem, is looking at your numbers and just trying to identify, okay, how are we getting to Y? Okay, so obviously there's a change being made to X. It's a constant change being made to all of them. Okay, so maybe you can just ignore the negative numbers and try and work with the positive numbers. It might be a bit easier. So when X is 0, we have 1, but then when X is 1, we have 6. Okay, so it might be a bit difficult to just look at it directly. So what you can try to do is try to sub it into the equations, right? So whenever you have X, so again, I'm going to try for 0 and 1. Let's try and sub it into A. If I sub it into A, I'm going to get Y is equal to 0 plus 6, which is 6. So that's definitely wrong because I'm supposed to be getting 1. Okay, let's try and sub it in here. Y is equal to negative 0 minus 4, which is minus 4. That's definitely wrong. Y is equal to negative 2 into 0 minus 9, which is equal to minus 9. That's definitely wrong. Or y is equal to 5 into 0 plus 1, which is equal to 1. So since only one of them worked, okay, only one of them worked, right? These were all incorrect. Okay, so only one of them worked. I don't have to check again. So I was actually going to check 0 and 1 just to be certain. But remember, this formula has to definitely work for all of them. And now since these three didn't work at all for 0, okay, only D worked, therefore D is the answer. Okay, so that's another method in multiple choice that you can use, is substituting values into what's given. Okay, let us do let us do it with the formulas. Okay, so remember, this is definitely a linear pattern. Okay, I'll tell you why. It is a linear / arithmetic pattern. Okay, the reason for that is if you look at all of our multiple choice, we can see a linear equation. So I don't know if you guys remember your straight line equations, right? So your straight line equations kind of look something like this, where you have y is equal to mx plus c, essentially. Okay, which represents a straight line, which represents linearity. Okay, all of those things along those lines, right? So when we talk about arithmetic or linear patterns, the equations are the same. Okay, so we have linear patterns, linear equations, that type of thing. And when we talk about a geometric pattern, right, which has R, I'm not sure how well you guys recall that lesson that we did, but the equation for this is A times R to the power of n minus 1. So in geometric pattern, okay, we have an exponent. Okay, and that's definitely not linear. It's not a linear pattern. You will never see a straight line equation that has an exponent. Okay, so that's what you want to sort of expect. So this is definitely linear / arithmetic. Okay, the same thing. This is a linear pattern. So in that case, we remember that the formula is, what is the formula? Jeez, yo, my memory is in the mud today. Tn is equal to A. Tn is equal to A plus n minus 1 times the difference. Okay, and we can substitute values. Okay, so remember in this case, okay, actually I scrapped that. That might not work. The reason for that is because we have negative numbers. Okay, so I don't know if you guys recall, but in our lesson, when we discussed arithmetic patterns, we said that n has to be positive. N has to be positive. Okay, so since n has to be positive, in this case, we're dealing with negative numbers. So here we're just dealing with a pattern, but it should work, man. It should work nevertheless. So let's try it out. Tn is equal to A plus n minus 1 times the difference. Okay, so what we're going to do is we're going to substitute 1 and 6, okay, into this formula to try and get a pattern. So remember, essentially how we can discuss it actually in this case is like y is Tn and n is x. Okay, because n is our input value, okay, which we substitute. So if we want to get the value of the 5th term or the 6th term, okay, that's where we substitute n, and it's like an input value, and it gives you an output of what the value of the term is, which is Tn. Okay, so in that case, we can say 6 is equal to, now first term, I guess we can call it 6 plus n minus 1, n is 1, or actually we leave n as n. It's 1 times the difference. Okay, we can calculate the difference. So remember, difference is T3 minus T2, which should be equal to T2 minus T1. So let's do T2 minus T1, minus 4 minus 9. This is equal to positive 5. Positive 5, positive 5. So we can call our difference 5. Okay, and actually what we have to do as well is we have to leave Tn as Tn. Okay, because we want a general pattern. Okay, we don't want, sorry, we didn't have to substitute there because we want a general pattern. Okay, we don't want, we don't have to substitute in. We're not solving for n in this case because we want a general pattern. Tn and n you leave as they are. So Tn is equal to 6 plus, let's simplify this. You're going to get plus 5n minus 5, which then simplifies to Tn is equal to 5n plus 1. Okay, so using patterns to solve for this equation works as well. So you're going to get 5n plus 1, which is essentially y is equal to 5x plus 1. Again, n and x work the same, and Tn and y work the same. Okay, so I hope that makes sense and I didn't confuse you even more. But yeah, I would think a better approach, a quicker approach would just be doing this, to substitute the values in. Try at least 2 values, okay, because an incorrect pattern is definitely not going to work for 2 values. An incorrect pattern might work for 1 value, but it's not going to work for 2 values. So try at least 2 values, substitute it into the pattern, especially since it's multiple choice. Like I said, alternatively, we could use this, where we're saying our first pattern is actually 6, because we want to work with the positive terms only in arithmetic. If we had to work with negative terms, let's see, it might work. -2, no, let's see, plus n minus 1 times 5, it's not going to work. We're going to get a different answer. Okay, so just keep that in mind, because if you want to use the pattern approach, remember that n has to always be positive and n starts at 1. So your first term is going to be whenever x is equal to 1. Okay, but yeah, let's continue. Okay, so let's have a look at this. Let me just open my notes for revision. 1 second. Okay, so ratios, okay, which is the first lesson we did on whole numbers. The first question says, write 21 is to 35 in its simplest form. So the methods we said that we can use for this is dividing both by the same value. Okay, so in this case, a number, we're looking actually for a highest common factor. Okay, you're technically looking for a highest common factor. Remember, a factor is a number that goes exactly into another number with no remainder. Okay, so what could be the highest common factor between 21 and 35? What do you guys think? Sorry, ICJ, it's cool. Take 7, right? Correct. 7 is very good. If you are good with your multiples, which you really should be, your multiplication timetables, it will be much easier to identify that, okay, I know that 7 can go back into both of these numbers. Alternatively, if you are really not good at it, with your multiplications, which again you should be, you could technically do HCF for 21 and 35, and then find the highest common factor. That's going to take you a long time for 2 marks. But ideally, you want to be good with your multiplications and be able to easily identify that 7 can go into 21 and 35, right? In that case, we're going to divide it both by 7. Okay, let me get out the memo so we can see where you're getting marks. Okay, you divide them both by 7. When you divide 21 by 7, you're getting 3, When you're dividing 35 by 7, you're getting 5. It's a 3-to-5 ratio. Okay, so even though it's 2 marks, you are basically, according to the memo, you're getting your marks for these ratios. You're getting both your marks there. It should be the other way around. It should be. It's fine. Okay, you're getting both your marks for the ratio. So technically, another way that you could do is, I'm not sure if we discussed, but we should have discussed it at some point. Remember, ratios can be written as fractions. Okay, ratios and fractions work hand in hand. This sign just basically means that these are the same. They represent the same thing. So ratios can be represented as fractions. Okay, so in your calculator, while you can't put a ratio, you definitely can put a fraction. So in your calculator, you can put 21 over 35. Okay, and it will simplify the ratio for you. That's going to give you, in its simplest form, 3 over 5, which therefore results in a 3-to-5 ratio. Okay, and since you're not getting your marks for dividing it by 7, you're going to get both your marks right there for just having the final ratio. Okay, let's look at the next question. Use the ladder method to determine the prime factors of 36. Write your answer in exponential form. Okay, fun stuff, right? Let's just revisit that. Okay, cool. Right. So remember, when it comes to prime factorization, people, what it means essentially is dividing by your prime numbers. What are our first? We should know at least the first 5 to 10 prime numbers. Okay. If you recall, we mainly literally just use like the first 5. So 2, 3, 5, 7, 11, 13, 17, 19, 23, and so on. These are our prime numbers. Okay, so when you want to write something, determine the prime factors of a number, or you want to do what we call the prime factorization of a number, you will need to divide that number by a prime number. Okay, any number, technically, you can do any number. You generally want to start off with the highest, but again, it really doesn't matter, right? Any number that you can think of that's a prime number. Well, you should know your prime numbers. The first prime number that you think of that goes into that number, you put it. You divide it by that number and so on, right? So here they drew up the ladder for us, but normally you'd have to draw up a ladder, of course. So let's do it. So 36, the first prime number, I can either choose 2 or 3. I'm going to choose, I don't know what you find easier, maybe 3, right? Because you're used to your 3 multiplication. You know that 3 times 12 is 36. So you choose 3. And then you say 36 divided by 3, that's going to give you 12. Okay. Then again, is this a March examination test? No, this is a November exam. Okay. So then when you divide it by 3, you end up with 12. So now you need to divide 12 by a prime number. So I'm going to divide it by 3 again, and I end up with 4. Now 4, I can divide it by 2, which is also a prime number. When I say 4 divided by 2, I get 2 again. And then finally, I can divide 2 by 2, and I'm left with 1. So you are done with your prime factorization. As soon as you have 1, when you end up with 1 on the left side, that's when you know, okay, it's done. I've done the complete thing. So, okay, so now they want us to prime factorization done using ladder method. They want us to write it in exponential form. So if you remember correctly, here we have 3 times 3 times 2 times 2. Okay, we have 2 3s and 2 2s, so we can simplify that as 3 to the power of 2 times 2 to the power of 2. Okay, I hope that makes sense. Let's have a look at this. The number 540 as a product of its prime factors is 2 squared times 3 cubed times 5. Okay, so let's maybe just write this again. 36 is equal to 3 squared times 2 squared. Okay, while 540 is equal to 2 squared times 3 cubed times 5. Okay, they want us to determine the LCM and HCF of 36 and 540 using the information given above, as well as your answer to question 2.2.1. Okay, so we don't have to do ladder method again for 36 and 540. We just can utilize the exponential form to solve for HCF. So now if we recall, let me do something. Let me go back to our notes. Give me 1 second. And you can have a look at it as well. Whole numbers. Okay, so now, okay, if we look at HCF and LCM, let's revise. HCF said, first we have to do the prime factorization of each number. Secondly, we have to identify the common factors. And thirdly, we have to multiply the common factors only on one side. Okay. LCM, lowest common multiple, stated that we need to do the prime factorization of each number. We need to write each factor in exponent notation and multiply each factor with its highest power. Okay, so let's start off with HCF. Now, HCF, we are not used to doing it with the prime factorization. Sorry, we are not used to doing it in exponential form, right? So what we could do is we could write it out ladder method and then follow from there. So 36 we have as ladder method done. Let's do 540. So 540, okay. Let's try that again. So I'm not going to actually do the division. Why? Because it's already given to us. It's given to us that it's 2 squared, so I know that I'm going to have 2 2s. Okay, 3 cubed, so I know I'm going to have 3 3s, and times 5, so I know I'm going to have 5. Okay, so now maybe this format we are more used to utilizing to solve for HCF. So the step said, let's do this. The step said that we should identify the common factors, okay, and then multiply the common factors only on one side. So if we recall, how do we do that? Okay, so we start off with 2 and we analyze. There's a 2 here. Is there a 2 on the right side that we can pair it up with? Yes, so we highlight that 2. Okay, then we look at the next number. It's a 2 again. Is there another 2 that we can pair it up with? We can get rid of this, by the way. Yes, there is. So we highlight the 2 only on one side and we get rid of the 2 there. Then we look at the next number, which is a 3. Is there a 3 on the other side that we can pair it up with? Yes, we can pair it up with that 3. So we highlight it and we get rid of that. Then we look at the next number. It's another 3. Is there another 3 in the factors of prime factors of 36 that we can pair it up with? Yes, there's a 3 there. So we highlight it again. We're only highlighting it in one set of factors. Okay. Then we look at the next number. It's another 3. Is there a third 3 that we can pair it up with in the factors of 36? No, there isn't. So we ignore. Let's look at 5. Is there a 5 that we can pair this 5 up with in the factors of 36? No, there isn't. Okay. So we ignore. And this is our answer to the highest common factor. Let's do it here. Okay. It is the highlighted factors on one side of in one of the factor sets. Okay, so it basically becomes 2 times 2 times 3 times 3. Okay, which in that case, all right, HCF is going to be 2 squared times 3 squared, which is 2 squared is 4, 3 squared is 9. This answer gives us 36. So 36 itself, okay, is the highest common factor between 36 and 540. Now let us revise LCM one more time. LCM says prime factorization of each number, write each factor in exponent notation and multiply each factor with its highest power. So we already have it in exponent notation. We just need to multiply with the highest power now. Okay, so the highest power of each. So we look at our factors. Remember, we are considering all the different factors in both sets of prime factors. Okay, so my different factors, I have a 2, I have a 3, and I have a 5. So I have to look for the highest powers of each of these. Okay, so let's look for the highest power of 2. Highest power of 2, I think, is just 2 squared. Let's use yellow. It's just 2 squared. Let's look for the highest power of 3. I would think that would be the cubed. So 3 is done, 3 cubed. Let's look for the highest power of 5. That would just be 5 to the power of 1. So in that case, for the lowest common multiple, we're going to say 2 to the power of 2 times 3 to the power of 3 times 5. This is equal to 4 times 9, 4 times 27, because 3 cubed is 27, times 5. 4 times 5 is 20, 20 times 27 is 414 or something. 2014, 540, never mind. Today is not my day, clearly. Okay, 540, and therefore the LCM, the lowest common multiple of 360 and 540 is 540. Pretty cool question, because HCF was one of the numbers and LCF was the other number. Okay, hope that makes sense. If you guys have any questions or if you're confused about something, please let me know, and then we can go through it again. But I'm going through it, doing revision, going through it slow so that you can understand how to do the questions in an exam context. Right, let's have a look at the next question. 2.3, worth 3 marks. It says 12 contractors can build an RDP house in 7 days. How many contractors working at the same rate will be needed to build the house in 4 days? Okay, so I don't know if you guys recall, we did direct proportion and indirect proportion, okay, which is what you need to identify from this specific question, okay, because they're asking you rate, the rate at which something is done. Okay, so when we talk about the rate at which something is done, are we talking about, is it done with an indirect proportion or direct proportion? So remember, direct proportion means just to say, we have to say A is directly proportional to B. Okay, that sign represents directly proportional, by the way. A directly proportional to B. So when A is directly proportional to B, so direct proportion basically means that when A increases, B also increases. I'm just avoiding writing all the English, right? I'm just doing it with symbols and stuff. And by that proportion also means that when A decreases, B will also decrease. Let's talk about indirect. Let's talk about indirect proportion. So indirect proportion, let's say B and let's just say A and B. Just say A is indirectly proportional to B. How do we represent that in terms of symbols? We use the same sign of direct proportion, but instead of saying B, we say 1 over B. Okay. And in that case, what that means basically is that when A increases, B decreases. So they indirect, right? They work indirectly. So when one increases, the other decreases. And then, okay, when A decreases, then B would actually increase. Okay, so they're opposite, while indirect, they do the same thing. So when we look at 2.3, what would we say is the relationship between, or what is this rate? Would you guys say it's direct or indirect? 12 contractors can build an RDP house in 7 days. How many contractors working at the same rate will need to build a house in 4 days? What type of relationship are we talking here? Direct or indirect? Okay, so when someone says indirect, what do we all think? Are we not sure? Indirect as well. Okay, so the correct answer is indirect. Okay, so let's discuss why. So think of it as the more people you have, the quicker it will take to build. Okay, so the more people, the more contractors. Okay, the less time, essentially, because that's our other factor. Our other factor is time. So time actually goes down because it takes less time. So when one increases, the other decreases. So we say indirect. Okay, so Yes, 12 contractors can build an RDP house in 7 days. How many contractors working at the same rate will need to build a house in 4 days? So are we expecting to have more than 12 contractors or less than 12 contractors to build a house in a quicker time? More contractors or less contractors, keeping in mind they're working at the same rate? What are we expecting here? Exactly, right? It's going to take more contractors if you want to get it done at a quicker time. So let's just go and revise proportion. Okay, so direct proportion as one quantity increases, the other does too. There's a constant ratio between the quantities. Okay, when we talk about inverse or indirect proportion, as one quantity increases, the other decreases. Okay, there is a constant product between the quantities, and so x times y is equal to k. So basically, for direct proportion, you will put your variables, or what do they call them, your quantities, as a fraction and equate them to each other like this. But for inverse proportion, you will put them as a multiplication and equate them to each other, basically as a product, and you will equate them to each other again like this. So let's go back to the question. Okay, so the question says, again, 12 contractors can build an RDP house in 7 days. How many contractors working at the same rate will be needed? Since we identify this as an indirect proportion, okay, we can multiply. So 12 contractors, so we can say contractors times hours is going to be equal to contractors times hours. So we have 12 contractors building it in 7 hours. We have an X amount of contractors, which we need to find out what that amount is, building it in 4 hours. So 12 times 7 is actually 90, 84. X times 4 is 4x. We divide both sides by 4. That cancels with that. 84 divided by 4 is actually 21. So 21 contractors would be needed to build a house in 4 days. Okay, I hope that makes sense. Let's move on. Arrange in ascending order. Okay, so ascending means from smallest to biggest. Ascending means going up, increasing. So how would you increase? When you start at the smallest and you go to the biggest. So smallest through to the biggest. And of course, descending would be biggest through to the smallest. So in this case, I definitely start with my, what's the smallest number? You guys tell me. What would be the smallest number? Okay, thankfully nobody said 0. So when we talk about the smallest number, we're looking for the number that's the most left on the number line. Okay, so essentially looking for the biggest in terms of value negative number, because the biggest negative number is going to be most the left. Okay, it's actually the smallest number. Okay, so I'm using that term loosely. So it's just the smallest number. So negative 62 is the smallest. Okay, then we'd end up with negative 55, negative 43, going towards 0, right? Then 0. Now we're going to go 0 upwards. What's the biggest number in the set? $25, correct? All right, so we're going to do 8. Then we're going to do 25. Okay, evaluate without the use of a calculator. Let me just check. Yeah, we did do. This looks so easy, but when it comes to this, I go blank. Also, sometimes like this is a department paper, so maybe sometimes internal papers can be a bit more difficult. All right, it's mostly like the concepts will definitely remain the same. It's maybe the way that they phrase the questions. Right, so if you ever come across a difficult paper, all right, you can send it to me and I can try and do it together with you guys in the class so that everybody can benefit from it. But yeah, like I said, the concepts are the same. It's just that probably the way that they phrase it and the type of the way that they approach the question can be confusing. Okay, so let's have a look at this question. We have root 49 again. So you need to know your perfect squares, right? Your perfect squares are going to be 1, which is 1 times 1. 2 times 2 is 4. 3 times 3 is 9, 16, 25, 36, 49. 8 times 8, 64, 81, 100, 121, and 144, which is 12 times 12. Okay, so you need to know all of these, right? Definitely. So therefore, you'll immediately identify that 49 is a perfect square. So root 49 is actually basically root 7 squared minus 2 over 3 plus. Now, negative 2 cubed, okay? You need to keep in mind that when you square a negative, you're always going to get a positive. When you square a negative, you're always going to get a positive because remember, when you square something, you multiply it by itself. And when you have negative x times negative x, a negative times a negative gives you a positive. That's why you're going to get positive x squared. Right? And so that's when you square something. Whenever you square anything, it's always going to be positive. However, with cubes, because you're multiplying it 3 times, okay, you're not always going to get a negative. Okay. You're not always going to get a positive, sorry. Actually, when you cube a negative, you're always going to get a negative. Why? Because if we look at negative x in brackets cubed, okay, this is equal to negative x times negative x times negative x. So if we do the first two, negative x times negative x, this gives us positive x squared times another negative x. Now it gives us negative x cubed. Okay, so just keep that in mind. So in that case, if we're going to cube a negative, we can expect a negative. Okay, so negative 2 cubed is going to be negative 8. Okay, then we have, so of course that's 7 minus 2 divided by 3 minus 8, which is equal to 5 over negative 5, which is then equal to negative 1. Okay, let's move on. Complete the exponential law by filling in the missing part. Times 5. Okay, thank you for that. Multiplied by 5. Okay, so yes, we're going to get 7 minus 2 over 3 minus 8 times 5, basically. This is equal to, we showed it's negative 1 times 5, which is equal to negative 5. Complete the exponential law by filling in the missing part. What is this? What's the missing part here? So of course, if you want to answer this question, you need to know your laws of exponents. You need to know them and you need to know them well. What would the missing part here be? Okay, kind of. Okay, but that may be a bit too far. Let me just quickly, we'll end on this. So if we look at our rules of exponents, okay, we'll skip all of them and go to the main one. We go to number 5. When you simply have, so this comes directly from your, from this law, okay? When you have a negative exponent, that's when you normally take it to the denominator to make it a positive exponent. So in this case, it would be a to the power of negative m, okay? Because you see there's no addition or subtraction here, okay? So that's why we wouldn't follow that one. I just wanted you to put the law. Okay, so let's end it there. And next time we will continue with 4.2. We did, oops. We did this question already, right? This is the patterns question. So we'll skip over that and we'll go through these last few questions, whatever we've done already, right? And we also, we've done finance, right? We done finance, okay? So there's actually a past paper we'll do next week that contains finance. Also, just remind me to go back to that first question and redo that first question. Please do 4.2. Unfortunately, we don't have time. Okay, I'm going to do it quickly, right? And then next week I'll do it again. I'm just going to give the solution. I'm not going to take too long, just for the sake of time. Okay, so we're actually going to have p to the power of 4x plus 4 minus, plus negative 2x minus 2. And it's divided by p to the power of 2, open brackets x plus 1. This is equal to p to the power of 4x plus 4 minus 2x minus 2 divided by 4 to the power of 2x plus 2. This is going to be p to the power of 2x plus 2 divided by p to the power of 2x plus 2, which is equal to 1. Okay, so I'll just give the answer. You can practice it and see if you get that, but next week I'll do it properly and explain it step by step. Okay, thank you guys so much for joining. I will see you guys next week. Enjoy your holiday. I'm suspecting that most of you guys are on holiday. And I will, see you guys next week. Same time, same place. All the best. Good luck. Jazakallah khair. Thank you. Assalamu alaikum.